Hello everyone. Welcome to another installment of CARBO's ongoing series entitled Results from the Field. My name is Terry Polish and I'm the Global Engineering Advisor, and today we'll be looking at our consolidated proppant technology, which we call CARBO Fusion, or Fusion for short, and case history in which we use that product in the Gulf of Mexico in a couple of injection wells. As we normally do, we'll go ahead and go through the features or the product itself, what CARBO Fusion is. So Fusion is our activated proppant resin coating system. And what's unique about it is that in addition to bonding in the fractures, like a typical curable resin coated proppant does, it also will bond in an annulus or a well or anywhere that does not have stress and temperature. In fact, we've had this bond down to as low as room temperature, 70 degrees. And so you can create a bond at proppant pack without the stress and temperature. It does utilize a special activator. That activator is pumped concurrently with the resin-coated proppant, so it's a single-step process. But it also allows working time so that you can do any work you need to do downhole with shifting tools or any other completion operations. It also incorporates CARBO's NRT, or non-radioactive traceable proppant technology. And this allows you to locate the annular pack and look at that quality not only after you pump the frac, but also well into the future because there's no half-life. Of course, it can be incorporated into any of CARBO's high-quality proppants, and as you're going to see in a moment, it is a field-proven technology. So what we're going to do is go through the qualification and case history of a Gulf of Mexico injection well for a major oil and gas operator in the Gulf of Mexico. So to look at the challenge that this operator had, as I think most of you know, typical resin, curable resin, does require stress and temperature to fully bond and lock in place. A resin-coated proppant in the fracture will bond, of course, but any proppant that's left in the annular area or annulus or in a gravel pack is going to remain unconsolidated. And if this were to be turned on to injection, and injection were to occur at higher than parting pressure or fracture pressure of the rock, what's going to happen is you're going to lose that pack in the near wellbore area and flush it away. And at that point in time, you have channels behind pipe. If the well is shut in, you then allow fines to ingress into the annular pack area. It may lead to a loss in injectivity because of that, and quite frankly, you could lose the well. The costs of this can be substantial, particularly in a deepwater offshore application. If you lose injectivity or you reduce injectivity or the injector itself, you're going to lose significant reserves because you don't have pressure support anymore. And the remedial effort here is going to be quite expensive. Even if it's a simple acid job, those can be very expensive. Of course, a workover is going to be multi-million-dollar operation. So this operator needed a proppant that would bond not only in the fracture and remain in place, but also bond in the annular area and remain immobile when placed on water injection. So the operator evaluated over 30 different potential solutions and eventually chose the Fusion technology as the technology of choice. Now, there were some key components that caused the operator to choose Fusion. First of all, it was incorporated with all of typical high-quality ceramic. In this case, we were incorporating it with carbolite. It also, of course, as we said before, it has the tracer technology so that they can monitor that pack integrity over time as they put the well on water injection or the wells. It is a two-component system, so it's a resin-coated proppant and it's an activator. When kept apart, they are not going to be reactive, but when put together, they become reactive, and of course they are a single component system, so you pump it at the same time. The activator is also not a resin softening system like a typical activator. It's actually promoting chemical bonding between the grains once they become in contact and have sufficient time to bond. Lastly, of course, the biggest issue here was it does then create a strong bond in the frac, but also in the annular pack area, as you're going to see in a moment after the extensive testing that was performed. Now, a lot of this is documented in an SP paper 180328, so I would draw that to your attention if you would like further details. So first of all, a extensive amount of lab testing was performed. I'm only going to show you a couple of them here. First of all, a lot of fluid compatibility testing was done with both linear and borate crosslinked fluids. In this particular case, we're looking at a viscosity profile for about an hour and a half, 2 hours. And the black line represents the base fluid, a 15-pound HPG crosslinked fluid. And then the blue and the red curves represent the viscosity profile of a 2 and a 3% activator addition. For this particular operator, the final activator addition was about 2.5%. In addition, significant amount of unconfined compressive strength testing, UCS testing was done. In this particular chart I'm showing you the difference between the three products available. So if we look at the standard curable resin coated proppant like 2040 Carbobond Light, if you try to set that with just 200 degrees and no closure stress, you would get minimal amount of consolidation. You can see it right here, maybe 10 psi at the most. Now, fusion resin isn't a specific resin for the system, but if you were to use it without the activator, you could probably double the strength of that bond, but it's still well below the minimum target of 100 psi. Of course, by adding the activator, you can see the plug here. This was generated at 200 degrees and no closure stress, and this plug has over 300 psi UCS. In addition, a significant amount of yard testing was done, both to understand how pumpable it was and the logistical side of things, as well as understanding any type of coating issues with sending it through pumps and valves. Once it was validated at the surface, 2 field tests were done. The first test was called the deployment only trial. In this particular case, we wanted to just test whether the fusion, the whole system, the deployment system would work, whether it would work with typical lower completion hardware. Could we mix it at the surface? What would happen if we pumped it and then we tried to shift tools? Would it behave as we expected in the laboratory? And then lastly, would it successfully create an immobile proppant pack? So to do this, a single onshore well was chosen in South Texas. This was a well that was going to be P&A'd, so they used this as a sacrificial well. In this well, they placed 3 different frac pack completion systems and placed activated fusion proppant in all 3 of those systems. Now, in each case, they used 80-pound HEC fluid system. This was one of the fluid systems that we tested in the lab, and it was at about 180 to 200 degrees reservoir temperature, which was right at where the offshore completion was going to be. Now, in the first multi-zone system, which was the lowest system that was in place, it was just really a feasibility study, the mixing. They shifted sleeves, did the things that you would normally do in this multi-zone system. They then let the product cure, ran logs, and showed very good annular coverage. So then they moved up hole and did the second system, which was a single zone frac pack system. In this case, they wanted to do a little bit more working of hardware. This particular job screened out actually. And when they went to reverse out, they didn't realize one of the valves were closed. And in doing so, they had to spend about 15 or 20 minutes before they actually got to the point of reversing out. So they actually unintentionally tested an unplanned shutdown and still were able to successfully reverse out. And in the last system, what they did was they simulated a screen out, and they actually then dumped activated fusion proppant on top of the ball valve, let it set, and then milled it out. So they wanted to understand whether it would be possible to mill out that system. From there, they also, though, ran logs, showed complete coverage after that, and then they also fished out the screens themselves and observed the pack itself and compared it to the log, and it also showed the same thing that the log showed. It had good coverage. The second test involved what was termed the long-term injection trial. And in this particular case, they wanted to understand if they were to put a well under long-term injection above parting pressure, would they still maintain that annular pack? So they chose an onshore well, again a test well in South Texas. This was a well that they drilled specifically for this work. However, it was going to be converted over to a produced water disposal well. They installed a cased hull frac pack. In this case, they used a Borate crosslinked guar fluid system, which was similar to what they were going to use offshore. They used 1630 carbolite fusion plus the activator, and again at a similar temperature. Everything went very smoothly. They pumped about 100,000 pounds in the job, about 97,000 they believe went into the frac, about 2,700 pounds remained in the annular pack, and about 9,500 pounds were successfully reversed out. The product was placed at a ramp of 1 to 8 PPA and at 25 barrels a minute. After the fact, they actually ran quality log 3 times across to see the NRT. The first time was immediately after the pack. If we look over here at the log, this track over on the right represents the NRT response. So you can see a very nice coverage across the entire screen and most of the blanks, so you get good coverage here right after the frac. They then put the well on injection and actually logged it 2 different times. One fairly soon after injection to see if anything changed, which is the blue line, and that had no change. And then after 5 months and about 1.5 million barrels, at which time they're injecting over parting pressure at 30,000 barrels of water a day, and that would be the green line. And as you can see, they all overlay. So this was successfully indicated that that pack does become immobile, and it remained in place the entire time, even after injecting over parting pressure. So based on this extensive field testing, they then went out to their 2 wells in the Gulf of Mexico. These are in the Deepwater Gulf of Mexico and are considered soft sands. So if a well is shut in, it will most likely have crossflow and does need to have a good pack in place to prevent any fines migration into the annular area. In this particular case, they used the Fusion Carbolite 1620 and anywhere from 20 to 40 gallons per thousand activator, which represented essentially 2.5% by weight of proppant. It was also pumped, as I said before, in a borate crosslinked fluid system. They ran logs after the frac, and they showed successful frac and gravel pack coverage. And now to date, these wells have had sustained injection rate of over 57,000 barrels of water a day, and injecting over parting pressure, and have withstood multiple shut-ins and shutdowns and still are maintaining their injection rate. This technology actually received an internal company award at with the operator for the system and for what it's done for their work. And not only are additional wells planned, but they actually have additional wells that have been pumped. So with that, let me just summarize. Again, Fusion is our proppant consolidation technology. It's a special case of resin-coated proppant. It's a system that bonds with, and most importantly, without stress over a very broad temperature range. It's an activated system that is run with the proppant at the same time. It also provides working time so that you can do all the work you need to do downhole with your downhole operations. It does utilize our NRT proppant tracer technology, so it allows you to monitor that pack for as long as you have the proppant in place. It has been field proven in multiple wells, both land and offshore. In fact, it's also been pumped in multiple other applications, unique applications that maybe will be a subject of a future case history. At this point in time, the operator who asked for this development has placed it in Deepwater Gulf of Mexico wells, successfully withstanding over 50,000 barrels of water a day and over parting pressure. Additional applications in this particular field have been completed and are currently ongoing. So with that, I'm going to close. I do want to draw your attention to our website at www.carboceramics.com if you want any other information about any of our other proppant technologies, or if you'd like to understand more about our field consulting or our frac software. And of course, as always, if you have any questions, you can contact me directly at the email that you see on the screen below. And with that, I want to wish everybody a good day.